Hey, hi. So I am Shubhanu. So good evening, everyone. So today is week 5 of our NLP course. So other weeks, so we will be starting our session by from this point. Yeah. So we will be in today's week also we will be looking into some of the questions from the topics that was covered in today's this week's lecture series. Basically, I hope you all have seen those video lectures. Okay, so we'll be starting from solving the some questions. Okay, so so this is the first question. Yeah, so you can give it a try and you can give it a try and answer, post your answer in the chat box. Okay, so I think you have already studied. You have already seen those videos from NPTL. So there, you have seen that there is something called CFG, context-free grammar, and CNF, Chomsky normal form. Okay. So yeah, thanks for answering. So Divya, you are answering B and C. Okay, let's see. Let's see what's the answer. Okay. First, what we want to do that we want to understand that what is a CFG and what is a CNF. Okay. Now, so our question is about which of the following are true. Okay. So we have to find out what is a CFG, what is a CNF. So we really don't know what is CFG and CNF. Let's find it out. Now, now, CNF, it's the Chomsky normal form. Okay. And CFG is context free grammar. Okay. Now, there is a different in between CFG and CNF. So in CNF, each rule either produces two non-terminal symbol, its single terminal symbol, or in some cases the empty string. So converting a CFG to CNF is the key step in our parsing algorithm. So for this conversion, we use CYK algorithm. Uh, Now, first we understand that what is a context free grammar. In what is a context free grammar in in Chomsky normal form, there are such rule, so that if we want to say that if it's a context free grammar, then there are such rule. So what are the rule? Let us follow this. Yeah. Now, so why we use CFG? So CFG is used to generate all the possible string given in a formal language. Okay. Now, in CNF, I have a start symbol. I have my LHS is equal to right as RHS. LHS will be non-terminal, and RHS can contain, the right hand side can contain a single terminal or two non-terminal, but it can't contain combination of terminal and non-terminal. Okay, what does it mean? The single terminal means like this. Okay, two non-terminal means BC. So these two are allowed. Now, uh, now again, two non-terminal means you can say like noun phrase. This is also allowed. Okay, but here, what are not allowed, what is not allowed, let us focus on that. Like NP, yeah, like if you give like the and N, so this is not allowed, because this is a terminal, this is a non-terminal. So combination of terminal and non-terminal is not allowed. Okay, and also a single non-terminal is also not allowed. Okay, so like this. So uh, now what we can do? So we can use a dummy non-terminal to the original terminal. Okay, so suppose my sentence is like this: NP the nominal. Okay, so this is not a CNF, because I have a terminal here, and sorry, I have a non-terminal here and a terminal here. Okay, so if I write this the to determinant, then it will be, this is a dummy variable. So this will be terminal and terminal. So this will be a CNF. Fine. Okay. Now, if yeah, uh, now, so can you tell me that among these, if I say G1, so G1 is let me use another color. Yeah, G1 is like S A S A Z A A Z Z, and I also have G2. G2 is, there is another grammar. So here I have S A S A Z Z A. Okay. So among these, which one is CNF? Which one is CGF? So G1 is the CNF, okay, because the production rules satisfy the rules specified for the CNF. Okay, this one is the so this one is our CNF. Okay, why? Because we know that the rules are a non-terminal generating a non-terminal generating two non-terminals. Okay, so these are two non-terminals, and also uh, this is a non-terminal. This is a terminal. Okay, terminal. These are two non-terminals, so these are allowed. But here, in this case, a non-terminal and a terminal is there. Okay, so that's why this is not a CNF. Fine. Now, what are the now what are the steps here to convert this CFG to CNF? So first, what you have to do, that you have to eliminate the start symbol from the right hand side. So suppose you are given a grammar like this. mm, Suppose you have given a grammar like uh, okay. Now, uh, so this is as context free grammar. Okay, you can check it. Okay, so and I have to convert it into CNF. Okay, so there are some problem here. So you know that the problem is here can't be a non-terminal generating two a non-terminal generating two non-terminals is a have to satisfy. Then a non-terminal generating a terminal, that has also has to be satisfied. Okay, so this is non-terminal, this is terminal. Okay, so X is non-terminal, Y is non-terminal, Z is non-terminal. So these two rules should be satisfied here. So I have to change like that. So what are the process? So first I have to eliminate the start symbol. Okay, then I will remove null, unit, and useless production. Okay, so what is a useless production? If a rule has a single non-terminal on the RISS, like A to B, like so this is a single non-terminal. Okay, then that doesn't mean actually. So so I'll replace with this B's production. I can replace this A to B's production. Okay, so this is a unit production. Okay, now how will I what will I do in this scenario? So our start symbol should appear right at the right hand side. Okay, so here you can see that start symbol is appearing the right hand side. So we will create a new production rule first, S0 to S. Okay, so the grammar will be like this: S0 to S, S to ASB, A to AAS, A epsilon, then B to S, so ASBS, given A, given BB. Now, what I'll do? So our grammar is containing a null production, okay, which is this one. Okay, right? So it's removal from the so if I have we have to remove this. Okay, so if I remove this, then our grammar will become so S0 to S, S to ASB. You can So what I have done, so uh, so so I have to, as a grammar. So basically, mm, as a grammar, I had a null production a to epsilon. Okay, so I have to remove this. Okay, so that's why what will I do? So I have to find out that what is this epsilon doing. So if I put if you put, so how, oh sorry, give me a second. So here you can see that in this scenario, what this epsilon is affecting. So it's affecting here, it's affecting here, it's affecting here. So if you, so a to epsilon. Okay, so I have what I had, that I had a to epsilon. So basically replace all a with epsilon. So it will become sb, epsilon sb. So I have written this one. Got it? So if I place epsilon here, it will become as. Got it? A is there. Now if I replace epsilon here, I have another epsilon here. Got it? How it is coming? Any problem, anyone? You can write in the chat box that if you don't understand this one, that how I am replacing the a to epsilon. So now similarly, I have also a null at b's end, b to epsilon. So replace all of this. Replace all of the b to epsilon. Now if we replace all of the b to epsilon, you will get s0 to s, s to as, asv, sb, s, a to aas, as, a, b to sbs, a, bb. Okay, got it? So basically here I had I had from there I had b to epsilon. So this is a null production. So what I am doing, I am putting epsilon here. So it is become as. I am putting epsilon here. So it is become s. Okay. And ASB and SB is also like the previous. So this is how I am changing it. Okay. Now it creates a unit production. Can you recognize which one is a unit production? So this is B. So unit production is B to A. So here, this one. This is a unit production. So this is basically this can be a situation. This can be a situation. Okay. So I told you back. I told you previously also that I can't have A to B. Okay. So that's why what I am doing, that I am removing this. How I am doing this? S0 to S, S to AS, given ASB, given SB, given S, A to AAS, given AS, given A. Now B to SBS, given BB, AAS, given AS, given A. Fine. So this is like that. So it create unit production B given A. Now, so if I remove all B to A, so I'll replace with A. Okay. So what I am doing, so you can see here. So previously I had SBS and BB. So I have SBS, SBS and BB. So with it I have to add all the rules of A. So AAS, ASA. So that's why AAS, ASA. Getting my point? So I removed this A, and in place of this A, I have add these two. Got it? So this is the situation. Okay, fine. Hmm. So this is the situation. And now, yeah. So now what happened? Now, uh, also removal of this unit production S0 to S from grammar. I have, so if I remove this, okay, so this will give me S0 to AS, ASB to SB to S. Yes, it's visible. I can see it. I think yes, it's visible. Yeah. So so I have to remove this S0 to S. So what I am doing, S0 to S, even A is B. I'm doing that. Yeah. A is B, even SB, even S. Okay. From A to AS, given AS, given A, and B to SBS, given BB, and AAS, given AS. Okay. Here now I have a problem that a removal of unit production. So this I have removed. I have a unit production which is S0 to S. Okay. So if I remove this, like I have the unit. सर थोड़ा सा धीरे बात करना चाहिए, एक क्लास ले रहा हूँ, मेरा रिकॉर्ड होता है और मुझे यूट्यूब में भी अपलोड करना होता है, तो प्लीज. सो AS to A, uh, AS to A, and then I have, yeah, this is the thing, yeah. Now now so I have also removed I have also removed this non-terminal, which is S to S, S to S, and S0 to S. Okay, so I have removed this from here. So what I am doing now, so in this production I have a rule like A to AS, this one, A to AS, and B to SBS, B to SBS, and B to this one, AAS and AS. Okay. So in this production rule, these all are terminals. A and B exist on the right hand side with non-terminals. Okay. So I have to remove them from the right hand side. Okay. So what I will do, so I will write like this. So it will be S0 to AS given ASB given ASB, S given AS given ASB given SB, A to X AS. So I am introducing a new variable called X is X. Okay, and A. Now I have B to S Y S given BB X AS given XS given X. Okay. So basically, my motto is this is how we can solve it. So I am introducing these two new variables here, X to A and Y to B, and I am putting this here. Okay, like this. So I'll finish this one, and I'll so these are pretty long step from converting CNF to CGF to CNF. So I am finishing. I am not going further. I'll do all of this, and I'll post in the uh, where I post it in that Google Drive. Okay. So our main motto was that given a CFG and the corresponding CNF, they produce a different language. So is it true? So it required 2n minus 1 production of step in CNF to generate a string W of length n, which we were seeing basically. For a given grammar, there can be more than one CNF. So which option is true? That I have to find out. So here B and C are true. Okay. So it requires 2n minus 1 production of step in CNF to generate string W of length n. And for a given grammar, there can be more than one CNF. Okay. So these two are true. So from here you can try it. So so I have already described you that what is the procedure. So these two are true. You know what is, I have given you the basic idea of CFG and CNF. Now I have shown some steps how to convert CFG and CNF, and also I have shown you the step how to add this non-terminal like x to a and y to b. Okay, so now you have to answer this question. Then consider the CFG given below. Now, how many non-terminals should be added to convert CFG into CNF? Okay, you have to answer this. So, can you write your answer in the chat box? So, like you have to start from yourself. Okay, so then only you will be able to understand. So, what I have to do, that I have to convert a context-free grammar to context is sorry Chomsky normal form. So I have to convert. So this is my given CFG. Okay, this is my given CFG. So I have to convert it into CNF. Right now we need to ensure that so for CNF I have some rules. So I have to ensure that all production rule should satisfy the CNF format. Okay. So what are the what are in CNF, what we have seen, that we have seen that each production rule must be of from A to BC. So here I am writing for you so that you should understand. So in CNA, all production must follow A to BC. So where A, B, C are non-terminal and C is not a starting string, right? Okay, so I'll write it in this manner, and A to A and S to epsilon. So what I'm saying that here I have to follow that A, B, C are non-terminal. So this is non-terminal, B is non-terminal, C is non-terminal. Okay, and C not is equal to starting string. Okay, or A to A. So NT is A is non-terminal, but this is a terminal. A is a terminal. Okay, so my production rule should satisfy like this. Okay, and S to epsilon. So this is only allowed if S is the starting symbol and does not appear on the right hand side of any rule. Okay, so what this says, so is allowed only if S is starting symbol and does not appear on the right hand side of any rule. Okay, fine. What are the rules? So what are my rules? My rules are S. So what are my rules? So so in CNA, my rules should satisfy these conditions. What are my rules now here? Here I have X, S, Y, S to P, V to Vx, and V to epsilon. Okay. So you can see that this is followed. This is violated. So V2 epsilon can only be here if is allowed only if S is a starting symbol and does not appear on the right hand side of any production view. But you can see V is appearing here, V is appearing here also. Okay, so this is not possible. So what I have to do? I have to eliminate the epsilon production. Okay. So what is the epsilon production? So this P epsilon is called the epsilon production. Okay. So where B appears, so B appears like this. B appears here, S to P, and T also appears B to X. Okay. So that's why we generate an additional rule by considering P as epsilon where it is possible. Okay. So what I will do that I can do like this. I can do X, S, Y, different P. Okay. And V to X. Okay. So what I'm doing here, why V2X? Because V is epsilon. So V given Vx is, so if this is epsilon, then it will become V given X from here, and I can write like this. Okay. So now I will introduce, okay, so okay. So, 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 so now from here, what I can introduce, I will introduce to non-terminal. Okay. Okay. So these will be the two new non-terminal. One is x equal to x, one is y equal to y. So from here, so if we rewrite our rule, it will become s given. So you can find it from here. So it will become x s y given p. V become p x given p. Okay. Now I have to ensure that it ensure a binary production. Okay, so we rewrite the rules that have more than two symbol on the right hand side. Okay, so you can see that here this XSY has more than two non-terminals. So you can see that I had the rule that I can only have two non-terminal in the right hand side. So but I have three here. So what I can do? So I have to split it. How can I split it? So I can write, so from here I can write S given XA. Okay. So I have three non-terminal here. So what I have to do? So this is not allowed in CNF. Okay. So that's why I will be adding a new non-terminal here. Okay. I'll introduce a new non-terminal here. Which is A. Okay. So for here, what I'll be giving A to SY. Okay. So now my final set of production will be, so the final set of production is, so what I have S to XA, I have A to SY, S to V, I have V to VX, I have V to X, I have X to X, I have Y to Y. Okay, got it? Fine. So what are the non-terminal I have added? So I have added this A, this X, and this Y. Okay. So how many are there? It's three. So the correct option is, yeah, correct option is D3. Okay, fine. Okay. So now the next question, we'll move here. So now the next question is, in the above question, how many different number of null production in CFG to CNF converted from? So how many different number of null production? So Thibia, you can answer also like this one. This one is easy. How many different number of null production in the CFG to CNF converted from? So how many null production are there? So I was starting from here. So is it asking for null production? So I was also confused here. So I was also saying that it is asking for null production in CNF form. Yes, it is asking for the null production in the final form only. So I don't have any. So first I was also thought that how many null production has been removed. So in that scenario I should be answering two. Okay. So, but here I have seen that one was S2 epsilon and another was V2 epsilon. Okay, so this was the two null production in my case, but it is asking for the final version. So, if you have derived the final CNF version, okay, sorry. Yeah. So if you have derived the final CNF version, they are asking for in the final CNF version how many null production you have. So you don't have any null production here. So this should be the answer here. Yeah. So this question is based on the above only. And how many different numbers of production rule or step in the CFG to CNF converted from? Yeah, so right answer is 7 only. Yeah, right answer is 7. So I have to find out that how many different numbers of production rule steps in the CFG to CNF converted form. So you can find it from here. So I have already shown it. Like I have already shown in details that what are the steps I have followed. So from there, it's easily calculated that how many different number of production rules step in the CNP to CNF. Okay. Now we have a big question that for so this will I have to use multiple time. Okay. So please note this one. Okay. So your first task is to note this one. Okay. Now my question is that using CKY algorithm, find the probability score for the most probable trees or for the sentence S1 as students play football with friends. So take some time to solve this. And the following question is also will be based on this question only. Okay. So that's why it's better that you write this one, you copy this one in your notebook. So is anyone at least trying to solve? So otherwise I'll start solving, or otherwise I'll wait. So can anyone confirm? Okay, let's start solving this one. So we know that there is a algorithm called CKY algorithm. So yeah, so I am inserting some pages. Yeah. So I hope at least you have copied this one. Okay. So this will be using many times. Okay. So now what I have to find, I have to use this CKY algorithm. So what does this mean by CQI algorithm? This means by COCK4, Asami, Yonkar. So their name of, this is the name of the scientist. So this is the algorithm for probabilistic context-free grammar. Okay. So I have to find out the probability score for the most probable tree of this sequence. Okay. For this sentence, students play football with friends. Okay. For this, what I have to do? So each word in the sentence is assigned probability from the PCFG rule. So you can see from here that from this PCFG rule, students is a noun. Okay. Got it? Now then, so what are the lexical probabilities? So first we write the lexical probabilities. Lexical probabilities. So what are these? So this is students, which is noun, and the probability is 0.15. Now I have play, have 0.34. Football, this is wait, um, so I have to build the CKY table. We apply the binary rule from the PCFG table. Okay. So how will I do it? You at least know this, right? So this is the word. Okay. So this is our word column. I should write it on the top, but I am writing here. So this is our POS tags, and this is our probability. Okay. So this table, I think you have understood. Okay. Is there any problem? Okay. So from where I am finding this, so from here you can see, from here student is a noun, and friends is a noun. So from here I am finding these and these all. Okay. Got it? Any problem? This is like pretty, like this is straightforward only. So from here only I am finding out this one. Okay. Any problem? Anyone? So if you are not getting it, like if you are not getting any particular point, you are not understanding, please do message in the chat box. I'll try my best to make you understand. Okay. So first, how will I proceed? So I have to draw a CKY parsing table. Okay. So for this, what I do, so for this, the base thing is like this. So if you write your sentence, like your sentence is students play football with friends. Okay. What will you do? You will do like this. If you write 0, 1, 2, 3, 4, 5. Okay. Now what will you do? You will draw a table. So your table will look like this. Okay. So here you will have, you'll start from 1, 2, 3, 4, 5. Okay. And here you will have 0, 1, 2, 3, 4. Okay. Okay. Now what I have to do? So now, so are you getting? So I have write it there. So now what I have to do with 0 and 1, I have noun. Okay. So this student is basically noun. Okay. With probability is 0.15. Okay. So 0, 1 means student. That's why I have written it between 0 and 1. Any problem? Anyone? Anyone not getting it? Now what I have? I have play 1 and 2. Between 1 and 2, I have play. So what is play? Play is verb, and it is 0.30. So this is verb, so 0.30. Okay. Now noun 0.10. This is football. Okay. Now I have a with, that is PP 0.10. And for friends, the POS tag is noun, and the probability is 0.20. Fine. Now what I have to do? Now I have to fill the table using the PCFG rule. So we now combine the adjacent word using binary rule from the grammar. So now I have to look into this table, this one. Okay. So if I look into this, so from here I have to fill up the table. So how will I fill up? So so can you tell me what will come appear here in this space? In this space. So from noun and verb. So I have noun and verb. So can you tell me? Yeah. So this is basically this is coming. So here I am getting VB VP. Okay. How I am finding VP? VP is coming from NN and VB. Okay. So it is coming from this rule. Got it? So and its probability is to calculate it. Okay. So the probability will be, so for noun it's 0.15 into 0.25. Okay. So 0.15 and 0.25. So it will be 0.0375. Hmm? So Thibia, your why our value is different? Can you find it out? 0.0375. Okay, so it will be VP. Here I have value 0.03. It is coming from here and here. So I have basically multiplying 0.330 into 0.10 into 0.30, which is 0.03. Okay, so that's why I'm getting 0.03 here. Now for this NN and PP, I am getting PB. PB is coming from PP plus NP. Okay, so from here I am getting uh, I am getting 0.1 into 0.30. That's why I'm getting 0.03. The PB will be 0.03. Okay. Now I have now what I have, yeah, 0.03. Okay. Now what are the other steps? Other steps are, yeah, from here I am getting S. So yeah, from VP and VP. Okay. So from here I'm getting S. S I am coming from NP plus VP, that is 0.0375 into 0.50, which will give you um, which will give you 0.0094. 0.004. Okay. Now you have DP, which is 0.015. So this DP I am getting from uh, 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 so basically BP I'm getting from so like this, play plus football plus with, this is getting me VP. Okay. So VP is I'm getting from VP plus PP to VP. Okay. So that's just 0.3 into 0.50, which is become 0.015. Okay. So this is become 0.015. Now I have uh, football plus with plus friends. So this give me NP. Okay. So basically NN plus PB give me NP. So that's why 0.10 into 0.40 is equal to, so it become, so VP 0.014 and from NP. I think NP here. Okay. So this will give me 0.012. Okay. From this I'll get if we add these two, then I'll get BP, which is 0.006, and if I and also I'll get uh, this one is 0. 0047. Then from this I'll get uh, S. S is basically 6.06 into 10 to the power minus. Fine. Now try to solve this one. So how will we solve this one? Has anyone tried how to solve this one? Yeah. So here I have to find out the using CQI algorithm, find the number of parse trees for the sentence. So I have to find out the number of parse trees. So students like painting, okay, and the probability score for at least one of the probabilities. Okay, fine. So what should be the answer? So you have to build like this. You have to build the CK table, CKY table like this. So you can. Hmm. So cast is noun for and noun 0.12, 0.20, and 0.15. Okay. So if we fill the table, then we will get. Hmm. So I have two options that I can combine. student and like. So if I combine student and like from, that is NN and VP, so that will give me VP. Okay. So NN and VP will give me VP. Okay. So I will fill 1 2 with 0.15. So it is 0.15 into 0.20 into 0.25, which will give me 0.0075. Okay. So I have VP here, which will give me 0.0070075. Okay, fine. Now, if I combine like and painting, so if I combine like and painting, it will give me PP. Okay, PP will come from VBNN. Okay, which is nothing but PP will come from 0.20 into 0.12 into 0.30, which is 0.0072. Okay, 0.0072. Now combining these two, I have 1, 2, and 3, 3. So I will get from this grammar, I will get VP and NN. Okay. Yeah. So we will find like this. VP, NN. So basically, so student like. So this is so NN is basically painting. Okay. And I already know that student like is VP and painting is NN. So if I combine this, I will get 0.0075 into 0. Okay, but it will come like this 0.0075 into 0.12 into 0.50. So it will become 0.0045. Okay. So additionally, so this is a possible option, and also this is a possible option in NNVP. So you can see here. So this or this. Okay. So I can go in this way. So here our NN will be students and PP will be like painting. Okay, are you getting my point? That is, I am saying that I have two possible options here. One is student NN and like painting VP, and another part is student like VP painting NN. So S to NN VP, S to VP NN. So I have two possible options here. So for this, I will get probability of 0.15 for S into 0.0072 into 0.50 is equal to 0.00054. Okay. Now, uh, so it appears that in S appears in 1 3 via two. So I can appear here in two different ways. This one and this one. So I have two parts tree. Fine. So for the first tree, I am getting 0045. For the second, I am getting 0054. Okay. So the total probability is 0.00045 plus 0.00054, which is nothing but 0.00099, which is equal to 0.99 into 10 to the power minus 3. So option 0.99 into 10 to the power minus 6. So this is the correct option. Got it? You want some time to copy this? here you are asking for, oh, sorry. So you are asking for that here in the question it is saying that using CQI algorithm find the number of parse tree. So I find out that parse tree is 2. And for the sentence and S2 is students like painting and the probability is score for at least one of the probabilities. Okay. So yeah, one of the if one of the probability is 0.54 or 0.45 only. So I was just figuring out that compute. So yes. So if you yeah. So you have two trees. One is 0 for one you got 0.0045 and another you got 0.0054. Okay. So that's the total probability is so that's why I have found out the total probability. So this is so you have to combine this. This is not like that for at least one of the probabilities you want to find the probability score. So you are saying that can I write 0.0045 or 0.0054? Okay. You want to write this here. Okay. You in your scenario that this is the right option. Okay. But the thing is that you got two. You got two three. So you have to combine it. Okay. So that's the main reason. So you can write a single like that. Yes, the correct answer will be 0.99 only. Okay. So there is a reason for combining these probabilities. Okay. So we are computing the total probability of generating the sentence under this grammar. Fine. So uh yes. So another thing is that why should I combine these probabilities? So if I combine these probabilities, the probability of a sentence is the sum of the probabilities of all its possible parse trees. Okay. So since the yeah yeah. So basically, if in probabilistic context free grammar, a sentence can have multiple parse trees. Okay. 15 minutes. So in probabilistic context free grammar, a sentence can have multiple valid parse trees. Okay. The the probability of a sentence is the sum of the probabilities of all its possible parse trees. Since each tree represents an independent way to generate the sentence. Fine. So that's why we have to since the question asks for at least one parse tree, we sum the probabilities of all valid trees. Fine. So this is why I have written the answer 0.99. Okay, now this is for question. Yeah. So this is the question. So if they will ask for the probability of one specific parse tree, then you can report it to 0.045 or 0.54. Okay, now the next one that I have a given sentence that probability of students enjoy cricket like playing like this, and so this is given like this, where N34 represents the sum of non-terminal spanning the segment cricket like words 3 to 4. Now, so if you break down, the left hand side interprets that the left hand side represents the probability of the entire sentence. Students enjoy cricket like painting. Okay, students enjoy cricket like painting under grammar G, while also ensuring that segment this segment cricket like this one is spanned by some non-terminal N34. Okay, now the right hand side, this one. So and the right hand side splits the probability into Pj. So this Pj, the Pj which might represent a prior rule probability of N34. Okay, and this one, this is ensures the sentence is generated given that cricket like this term is already derived by N34. Got it? So what I am saying that first you have this one. First you have this in yellow color. You have the left hand side. Okay, this is your LHS, and in blue color you have the right hand side. Okay, RHS. Okay, so listen to me carefully. That in LHS, in LHS, LHS represent the probability of the entire sentence. This represent the probability of the entire sentence. Students enjoy cricket like painting under this grammar G. Okay, uh, while also ensuring that this segment cricket like here is spanned by some non-terminal. So this is a non-terminal N34. Okay, in the right hand side, this Pj is our prior probability of N34, and this this ensure that the sentence is generated given that cricket like is already derived by N34. So my in my sense, correct option is option B. I think. Let's see. Yeah, correct option is option B. So because this correctly states that the left hand side is the probability of the sentence ensuring that cricket like is spanned by consistently is that a non-terminal in 34 covered were 3 and 4. Okay, so this is the acceptable answer. Okay, now we'll move to this one that oh, we have already done this. Okay, okay. So I think this was the last question from today's class. Okay, thanks everyone for joining. We'll meet in next. We will meet in next week in the same time. So the timing is from 7 to 9. Yeah. Okay. Fine. Fine. Thanks everyone for joining. Okay. 1 to 4. 1 to 4 mean. Do you mean question 1 to 4? Question 1 to 4. Okay. Yeah. In question one, I have something called CFG to CNF. Okay. So I have to convert the context-free grammar into Chomsky normal form. So where I have some certain rules for the CNF. So you have to read it. What are the certain rule of CNF? So that's how I can convert our CFG into CNF. So I was trying the steps here. So in the second question, I have given a context-free grammar. I have to convert it to CNF. So here I have given the all the rules that which is applicable for the CNF. In CNF, you have non-terminal to non-terminal. You can have non-terminal to terminal. You can have a source to epsilon. So this you can have. Okay, but here in your given rule, there are problem that here you have epsilon probability, but this v is not. So I have written that v if v if this is the case that s to epsilon, then This is allowed only if S is the starting symbol and does not appear on the right hand side of any rule. So, but here you can see P is appearing right hand side. So that's why I have to convert it. I have converted it in a way. I am not repeating it. You can find it in the you can find it anywhere only. Okay. So this B to epsilon is replaced. Then I am introducing some two non-terminal x to x, y to y, and then also a. Okay, so I have added three non-terminal here. So this was the question, then how many non-terminals should be added to convert CFG to CNF? Now this is my final CNF expression from the context-free grammar. Okay. So in this question, I was asked that how many different null production are here in this equation. So in this CNA production, so I don't have any non-terminal null production in this production. So that's why I have given 0. Then I had the question that how many different number of production rule steps in CFG to CNF converted from. So I have done all this. Like I have tried to figuring out that what are the steps I have followed here from converting CNP to CNF. So I think I covered here. So I didn't. I am not going into depth here. That there are 7 steps it took me from converting CFG to CNF. Fine. Anything else? Okay. Okay. Thanks everyone for joining. We'll be meeting in the next week. Yeah. Okay. Okay. Fine. Thank you. Thank you so much. Thank you so much, everyone. Question 5 answer. Question 5. What was the question 5? Question 5. Let me check. 1, 2, 3, 4, 5. Yeah. Yes. Yes. So question 5. There is a ambiguity in question 5. So I am finding out that it's 6.06, but in the answer it's 1.62. I think. Okay. So you try it out. I have given you the way that uh Okay, so for question 5, first, okay, I'll give answer to each of these. So first question 5, for question 5, yes, I have given you the way. I have tried to, so I have to build the CYK table. Okay, so this table, you know that you always derive a table from the memorization, minimization, like or from the that but for the dynamic programming. This is a table, same kind of table from that only. So you learn the algorithm from the video, and then you try it out. So you will get it only. So you have to finally find it out this value. Okay, this value you have to find it out. Okay, so from my calculation, I am getting 6.06. So first you have to find. So everything is given here. So the lexical analysis and all, so the lexical probabilities and all is given here. Okay, so you have to find out these values from there, and you have to fill the table. So from my analysis, I am getting 6.06, but the given answer is I am seeing that's B. B means they are saying that answer is 1.62 into 10 to the power minus 6. I don't know that why it's this. So I have tried to solve it. You also solve it again. Then tell it to me that in the next class what was the answer. Okay. Okay, sir. Please explain question 2 again. Could you explain question 8? Okay. So there are more demand for question 8. So what was the question? Hmm. So have I missed something? Oh, I think I have missed this question. How many grammar has valid CNF? I have missed this one. Which of the grammar are valid CNF? So here there are three non-terminals not allowed. Here I have B epsilon, BB, Now I have C redundant. This is also not allowed. Not allowed. Okay, not allowed. I think D is allowed. D is allowed. Okay. Yeah. Sir, question number two, what is the correct answer? In question number two. So is this question number two? Yes. Question number two, correct answer is three. Fine. Okay. So another query. Question number two is clear for all of you. Okay. Now another query is uh, question number eight. So is this the question number eight? Can anyone confirm this one? Are you talking about? Oh, okay, okay. Oh, I have already shown it. This one. Okay, okay. Yeah. So here, how many, which of the following grammar are valid CNF? For this, you have to come here. I have already written the rules here. So what are the rules that you have to follow? That in the valid CNF, you can have this one. That A to BC, which is a non-terminal to non-terminal to non-terminal and non-terminal. Then A to A, non-terminal to terminal, and S to epsilon. But S should not be anywhere in any. Uh, it should not S should not appear in the right hand side in any of the production rule. Okay, so you try to memorize this. Non-terminal to non-terminal and non-terminal is allowed, and non-terminal to terminal is allowed, and S to epsilon is allowed. Okay, so now go back to your question. Yeah. So here I have non-terminal. So I have three. I have three here. Three non-terminal here. So it should not be allowed. Okay. And now here I have B epsilon and I have BB. So you see for a single production rule, I have two things. Okay. For B is producing epsilon also, and B is producing B also. So this is not allowed. Fine. And for C, here you can see there are three redundant things. So you have to merge it if this is the case. So only I have this possible option, which is A is non-terminal, this B is non-terminal, C is non-terminal, A is non-terminal, and terminal. So this is I can see is a possible option. So that's why D is the correct answer. Okay. Fine. Now, sir, can we get the slides for preparing by any means? Yes, you can get the slides anytime, but I will suggest that prepare from sir's lecture. Okay, I am not a good teacher at all. So prepare from sir's lecture. Okay, so from the NPTL. Yeah. Okay. Okay, Oscar. Okay, fine. So thanks all for joining. I think that's all. Anything else you want to ask? Anything else you want to ask? You can, or I'll leave the meeting. Okay. Thank you. Okay. Thanks. So thank you so much for joining. कहाँ जा रहे हैं हम? JNU? कहाँ जा रहे हैं?